Hello children, I once again welcome you all to online tutoring class for class 9 science. So in the last class, we started on a topic that is work and energy, chapter 11. And then we have done almost most of the topics and only few topics left. So this class will be the continuation of the last class. That means we are going to continue with the same chapter, that is work and energy. So in our last class, we have covered till kinetic energy, and then we discussed a little bit on potential energy, and also I gave you some examples on potential energy. But then we couldn't finish the potential energy, so today also we are going to start with the topic potential energy. So potential energy is nothing but basically potential energy is known as stored energy. That means stored energy means the energy that is stored in the body and it has been utilized by the object for further action. We call it as potential energy. And yesterday I gave you one example. When we sleep, we are preserving and we are storing energy so that it can be utilized after when we woke up from our sleep. It can be utilized when we do the daily activities. So the energy that is stored while sleeping, we call it as potential energy. And potential energy can be defined as, let me write, energy stored in the body by virtue of its position, and its configuration. Energy stored in the body by virtue of its position and its configuration, we call it as potential energy. Now let us divide this definition into three parts. Okay, so energy stored in the body will be, first part, by virtue of its position. Let's say this is the second part, and the third part is configuration. So let me explain it to you one by one, what is meant by energy stored in the body, what is meant by its position, and what is meant by its configuration. So energy stored in the body, that means yesterday I think I gave you this example also, but let me again explain it to you once more. So energy stored in the body means, for example, a toy car. Yesterday I gave you this example of a toy car with that have a key, right? So in order to let the toy car move from one place to another, you have to wind the key, right? So when you are winding the key, that means you are doing some work, and the work is done on the object, and the object is nothing but a toy car. And while you are doing a work, that energy is getting transferred into the into an object, that is a toy car. That means the energy, the work done is getting transferred and it's getting stored in the energy in the toy car, and that stored energy and that energy that is stored in the toy car, we call it as potential energy. And after you stop winding, after you leave it, what will happen? The toy car will start moving, right? That means the toy car is utilizing that stored energy that you have stored while doing a work, and then it will start moving. It will start moving means, as I have said, anything which is in motion, something which is moving means kinetic energy, right? So that means the potential energy that is stored in the toy car is again converted into kinetic energy, and that is how the toy car will start moving. So this is called energy stored in the body. And the second part is by virtue of its position. When I say by virtue of its position, it means even its position also gives energy to the body. Let me give you a very simple example. For example, a hammer. Okay, a hammer falling from a higher height or a hammer falling from a more height can fix the nail deeper, right? I hope you understand this meaning. That means when you are raising the hammer, that means when you are raising the hammer, you are doing some work, and that work is being done on the object, that is hammer. And when you are doing that work, the energy is getting transferred. That energy is getting transferred into an object. That object is nothing but the hammer, right? So the energy is getting transferred into the object, and it is getting stored inside the object, that is hammer. And later on, you hammer it on the nail. That means you are utilizing that stored energy, and that stored energy is nothing but what? Potential energy, right? So here the potential energy stored in this object, that is hammer, is due to its position. That means the way you raise your hand. That means the more you raise your hand, the more energy will get stored inside the object, and that is how the nail will go deeper. So it is because of the position. That means even here the position, it matters a lot. So this is called by virtue of its position. And the third is by virtue of its configuration. Configuration means change in shape, right? So let me give you again another example. Say a bow and an arrow. So I am sure you all know what is bow and what is arrow. So place an arrow inside a bow and then stretch the string, okay? So while you are stretching the string, that means you are doing some work, and the work is done on the object, that is a bow and arrow. And when you are doing that work, that means energy is getting stored inside the bow and arrow. And when you leave it, the bow will fly off in the air, right? That means the potential energy that is stored inside the object is getting transferred into kinetic energy, and that is how the arrow will fly off in the air. That means in here you notice that there is a change in shape, right? There is a change in shape. That means the more you stretch the string, you can shoot the arrow to a larger distance. So even here, even in this case, the potential energy that is stored in the object is due to the change of shape. That means is due to the configuration, which is then used in the form of kinetic energy, and that is how the arrow will fly off. So this is called potential energy. So and potential energy is nothing but energy stored in the body by virtue of its position and its configuration. We call it as potential energy, and the unit of potential energy is again joule. And also potential energy is denoted by the letter PE. Just this is P is potential and E is energy, or simply we can just write U. Okay, potential energy is PE or U, and the expression for this potential energy is mgh. This is the expression for this potential energy. Now let us find out how we got this expression, that is mgh. Say okay, let us suppose that we have an object. Say object, we have an object one, say this is ball and the object is ball, and this ball has mass m. Okay, the mass of this ball is m, and there is a say one building, and this is ground, and the height of this building is let's say this is h. So you have an object that is ball. So you have taken the object ball to the top of the building. Okay, now the ball is over here. That means in order to take the ball on the top of the roof, you need a force, right? So the force that is exerted on the object is nothing but because of here this is ground, because of the gravitational force of the earth. And so this gravitational force is equal to the weight of an object. That is, weight of an object is nothing but the mass. So force, we can write mass into acceleration, or just simply we'll write F is equal to mg. Okay, so now let us find out the work done of this object. Okay, let us find out the work done of this ball. So work done is equal to force into displacement. Force so work done is equal to force into displacement. So what is force here? The value of force here is mg, right? So let us put the value of this F here over here. So mg, and the displacement is what? Displacement is nothing but the height of the building. That means the ball has been displaced from this position to the top of the position, top of the roof. So the displacement is nothing but h. So this is h. So if we multiply this two, then we got mgh. So this mgh is nothing but the work that is done on the object to reach at the top of the building. Okay, this is nothing but the work that is done on the object to reach at the top of the building. So whenever the work is done on an object, it is stored as a potential energy. So we can say that potential energy is nothing but mgh, and this is the expression for this potential energy. M is nothing but the mass of an object, g is an acceleration due to gravity, and h is height. So I hope all of you are clear with this. In the previous class, I told you that there are different forms of energy, like potential energy, kinetic energy, chemical energy, heat energy, light energy, and heat energy. That means there are different forms of energies. So now what are we going to study is whether all these forms of energy can be transformed from one form into another. That means you can turn to your page number 165. We are going to study whether various forms of energy are interconvertible. That means whether they can be converted from one form into another form. Let me give you some few examples. The first example is when we feel cold, right? When we feel cold, we usually rub our hand like this, right? That means when we are rubbing our hands, that means we are doing some work, right? We are doing some work, and that work is nothing but mechanical work. Mechanical means movement is taking place. That means we are doing a mechanical work, and when we rub our hand, we feel warm, right? Our hand feel warm. So that is nothing but mechanical work. Mechanical energy is converted into heat energy in this case. Again, another example, say fan. Okay, fan. When you switch on the switch of the fan, then the fan will start moving, right? The fan will start moving. That means the electrical energy is converted into anything that is in motion. Movement means kinetic energy, right? So the electrical energy is converted into kinetic energy. Again, another example, say microphone. In a microphone, that means to use a microphone, we have to connect it in the electricity, right? That means even here, the electrical energy is converted into sound energy. Again, and so many examples I have given, like the same thing, the toy car. That means there also, in that case also, the potential energy is converted into kinetic energy. And the same example again, the bow and arrow, even there, the potential energy is again converted into kinetic energy. So from all these examples, we can say that energy can be converted from one form to another form. So, okay, let us go to the next topic. The next topic is law of conservation of energy. That is in page number 165. So what is law of conservation of energy? Law of conservation of energy states that energy can neither be created nor be destroyed. It can be converted. It can only be converted from one form to another form. It can only be converted means I have given you so many examples, right? Energy can be converted from one form to another, but it can neither, the energy can neither be created nor be destroyed. That means it will not increase or it will neither decrease. It will just remain as it is. That means the total energy before and after transformation will always remain constant or is conserved. And the only thing that will the change will take place is it can change from the energy can be converted from one form to another, but it can neither be created nor be destroyed. That means the total energy will always remain same, that is constant. And okay, so we have only one topic left for this chapter. that is rate of doing work. Rate of doing work. So what is rate of doing work? Rate of doing work is nothing but how fast or how slow a work can be done. How fast or how slow a work can be done. So whether different people can do the same work at the same time interval, or whether different people can do the same work at different time interval, we are going to study from here. Okay, so let me give you one example. Say there are two students, say one student is A and another student is B. Okay, let us say there are two students A and B, and both have same weight, say both have 50 kg, and the body weight of B is also 50 kg. So they started climbing up the rope, okay. So they started climbing up the rope separately. So A reaches a height of, say, 10 meter, okay. A reaches a height of 10 meter, and also the same thing, the B also reaches a height of 10 meter. But then A took, say, 5 minutes. A took 5 minutes to reach a height of 10 meter, whereas the student B took 10 minutes to reach a height of 10 meter. The question here is, what is the work done by A and what is the work done by B? That means what is the work done by both of them? So here in this case, work done is same, right? That means both have climbed the same rope, even though separately. Both have climbed the height of 10 meter, but then the time taken by A is less than that of time taken by B. So from here we can say that different people can do the same work at different time interval. That means some people can do work very fast, and whereas some people can do work very slowly. So the how fast or how slow the work is being done, or the speed of the work is measured by something, okay, is measured by something, and that's something we call it as power. So what is this power? Power is nothing but rate of doing work. So rate of doing work, we define it as power, and this power is denoted by the letter P, and the unit of power is W-A-T-T, watt, in honor of a scientist named James Watt. And power can be written as power is equal to work divided by time, or simply we can write W by T. So this is the formula for power. So we have come to the end of this topic. So far we have covered 3 chapters. I have covered 3 chapters, that is chapter 9, 10, 11 from physics. And in the first 2 classes, Sir Bentingo, he took 1 chapter from physics. That means altogether we have covered 4 chapters from physics. And also before lockdown, many schools, almost all the schools, they have covered 2 chapters, that is first 2 chapters, that is from chemistry. So that means altogether 6 chapters covered, right? So now we will take one new chapter, we will start a new chapter that is from biology, okay? So without wasting any time, since we don't have much time, so without wasting any time, without just recap, we will not do any recap, but straight away we'll start with a new chapter that is from biology, chapter number 5. Chapter number 5, that is page 61. I want you all to turn your textbook to page number 61, that is chapter number 5. So we will start with a new chapter, that is chapter number 5. So in this chapter, that is chapter number 5 from biology portion. So in this chapter, we are going to discuss on a very important unit of our life. Okay, we are going to discuss on one very important unit of our life. That the unit here I'm talking about is very small unit, okay. This is, the unit is small, the unit is small. This, we are going to discuss on a very important unit of our body, and this tiny units comes together, okay. Tiny unit comes together and gives us life. And this unit is very small, very tiny, that it cannot be seen with our naked eye, but it has a great impact in our lives, and our existence is possible because of this unit. And this tiny unit, so this unit may be very small and it may be very insignificant, but it is very important in the history of science. So the very small tiny unit that we are going to discuss in this class is nothing but, we call it as cell. Cell. So today's topic, now the chapter we are going to discuss is the fundamental the topic for this class is the fundamental unit of life, that is chapter 5 from biology. So fundamental means what? Essential, right? ESS. Fundamental means essential. So the most essential or the fundamental unit of our life is nothing but, we call it as cell. So this cell is the basic structural and functional unit of all living organisms, and this cell is a Latin word. Latin word, we call it as this cell is a Latin word for a little room. Why it is called little room, we'll discuss about this later as we go on with the lesson. And this cell is also known as building blocks of all living organisms. When I say building blocks of all living organisms, it means every living organism, whether it is plants, whether it is animals, or whether it is human being, we are made up of this cell, and that is why we call it as building blocks of all living organisms. Okay, let me again explain to you what is this building blocks. Okay, when I say building blocks means what? Let me give you one simple example. Say there is a big building, okay, there is a big building. So if I ask you what is the building blocks of that building, then what will be your answer? The building blocks of that building is nothing but the bricks, right? The bricks of identical shapes comes together, brings together, and then the entire building is being constructed, right? That means that bricks is the building blocks of that building. Similarly, our body, every living organisms, as I said, every living organisms, whether it is plant, whether it is animals, or whether it is human being, they are made up of cells. That means our body, in our body we have millions and millions of cells comes together and our body is formed. And so we can say that cell is the building blocks of all living organisms. Now let us see who discovered cell and how. So this cell was discovered by a scientist named Robert Hooke in 1665. So Robert Hooke discovered cell in 1665, and Robert Hooke designed his own microscope. Okay, in that time, Robert Hooke discovered his own microscope, that is self-designed, and with the help of this self-designed microscope, he used to observe so many objects, so many different objects. So one day, out of his own curiosity or out of his own interest, he observed a slide of a cork. So when I say cork means what? Cork is made from a bark of a tree, right? So he observed a cork of a slide of a cork, and what he see is he observed the slide of a cork of a he observed the slide of a cork, and from there what he observed was there was an empty space. The structure of that very cork was, under the microscope, the structure was somewhat like this. That means empty space, right? empty space with walls. It was just like empty space with walls, which resembles a honeycomb. We all know what is honeycomb, right? So he observed that the structure of that very core resembles the honeycomb. So it is just like a little room, right? Earlier I told you cell is a Latin word, we call it as a little room. So it is just like a little room joined together. That means it is like a compartment, small compartments coming together and then forming this shape. So he observed that the shape of this was like an empty space with walls. So from there he finally concluded that every living organisms are made up of such components, and he called this empty space, or he called this little rooms, or he called this little compartment as cell. Okay, so this is all about how the discovery of a cell. Now again, cell in living organisms, cell is again broadly classified into two groups. That is in living organisms, cell is again divided into two groups, that is unicellular organisms and then multicellular organisms. So this classification is based on the number of cells present in an organism. So when I say unicellular, what do you mean by unicellular? Just by the name itself, uni means one. Uni means one, right? Uni means one, or just say, we can just say single. And cellular means what? Cellular means cell only. That means those organisms which have only one cell, which have a single cell, we call it as unicellular organisms. And when I say multicellular, multi means what? Multi means many, right? Many. And cellular means again cell. So those organisms which have many cells, then we call it as multicellular organisms. We'll study them one by one in detail. So the first is unicellular organisms. So as I have said, unicellular organism, it means that those organisms which have only one or single cells, we call it as unicellular organism. That means that in the entire body of the organisms, they have only one cells. That means in the entire body of the organisms, there is just one cell, and that one cell alone constitute the structure of the organisms. And not only that, but this since they have only one cell, this single cell or this one cell perform all the functions of all the functions in the body. Okay, that means this organism is dependent on just one single cell. The single cell performs all the functions as a whole. So we can see that since it is a single cell and it performs all the functions, that means it performs the functions of the digestive system. This single cell, it performs the function of digestive system. Again, this single cell, it performs the function of excretory system. Again, this single cell, it performs the function of circulatory system. That means all the body, in every function, this single cell performs. So let us see some of the examples of the unicellular organisms. So examples of unicellular organisms are amoeba, paramecium, and Chlamydomonas and bacteria. All these are unicellular organisms. Okay, so all these organisms are microorganisms. When I say microorganisms, means they are very small organisms which cannot be seen by our naked eye, right? So all these are microorganisms, and all these organisms are called as unicellular organisms. That means they have only one cell, and that very one cell performs all the functions of the body. So now let us see what is multicellular organisms. As I have said, multi means many and cellular means cells. That means Those organisms which have many cells, we call it as multicellular organisms. The best example we can give is we human being, right? We human being, our body is made up of millions and millions of cells. That means more than one cell. So the best example for this multicellular organisms is human being. And in multicellular organisms, different functions are performed by different groups of cells. And in multicellular organism, division of labor takes place. This is very important again. Division of labor takes place. When I say division of labor takes place, that means work is being divided among different groups of cells. Okay, work is being divided among different groups of cells. Say like there are millions of cells in our body. So cells of similar type will come together in a group, and then they will perform some function like digestive system. Another group of cells of similar type will again come together and form another group, and they will perform again another function like circulatory system. Again, another group of cells of similar type will come together, and then they will perform again another function. So in this way, the cell performs a different functions. So as I have given you, the example is human being, right? So in human being, different parts of our body perform different functions. That means in the we have a heart to pump blood, right? Or we have a stomach for digestion. Again, we have an excretory system to excrete the waste material. Again, we have a we have a skeletal system to support and protect our body. So likewise, there are different parts of the body performs different functions. That means our body is made up of millions and millions of cells, as I have said earlier, and this group of cells come together and perform a certain functions. So the group of cells that comes together and perform a specific function, we call it as tissue. Okay, tissue. We will not be discussing about this tissue in this class, so because we will be discussing about about tissue in the next chapter. Again, another point here about multicellular is in multicellular organisms, there are cells of various kinds. So again, example is human being. Cells are of various kind means in our body there are varieties of cells are present. For example, in our brain we have a nerve cell, right? Or we have in our kidney we have a kidney cell, or in blood we have a blood cell, we have a skeletal muscle cell, and so on. And all these cells, they are of different size, of different shape, and their functions are also different. That means no two cells will perform the same function. That means the size, shape, and functions are different. Means the size, shape, and function of blood cell will be different from that of nerve cell. Again, it will be different from that of skeletal cell. That means different cell, different group of cells perform different function. So in multicellular organisms, that is those organisms which have many cells, right? So the group of cells of similar type comes together to form tissue. Again, the group of tissue again comes together to form organ. Again, the group of organ comes together to form an organ system. And finally, the organ system comes together to form a very important thing, that is you and I, that is living organisms. So this is the level of organization in multicellular organisms. So today we will stop from here. We have so many things to cover, so we will continue in the next class. Thank you.